Anyways, with this next question, right? It says the following. Question number 4. We have gone through the question 1, 2, and 3 in the previous tutorial. So question 4 here, it says for which values of x in the interval 0 to 180 is f of x smaller than 0. Now, a question that's going to ask you where is f of x smaller than 0. Remember, f of x stands for y. You see, so this question is practically asking you where is y smaller or equal to 0, or rather, where are the y values of x smaller or equal to 0? So your image is easily going to show you that, because on your picture, it's easy to see that this is an x-intercept, this is also an x-intercept. Now you can see that the graph is equal to 0 here and here. It's below 0 here all the way until there. So if you're going to give an answer, you're just going to say from this x value until this x value. You can already see our task is to just know what this x value is and what this x value is. And from our previous tutorials, we said that because f of x is cos to x, it's just a cos graph that has a frequency of 2. Meaning in a space of 360, you'd see 2 graphs, you see. Meaning halfway at 180, you'd see one complete graph. And then 180 degrees again, you'd see another complete cos graph, you see. So this goes up until, I'm using an image until 360 because that's like one that's easy to work with. So in the middle here, we already know that we have 180. And then we know that obviously, the easiest way to work out this and this is to judge according to the original cos graph. An original cos graph from 0 to 360, right? You would see something like this, where this point is a 90, this point is a 270, this point is 360, and this is like a 0. Now, if your frequency is a 2, it means that all these specific values here, they get halved, because in a space of 360, you're supposed to see 2 graphs. So where this was like a 90, you would now see it halfway, which is like a 45. Where this was 270, you would now see it halfway, which is like 135, you see. So this, it's 45, this, it's 135. But with most people, I mean, like, they would have been more comfortable just saying, okay, where is f of x equal to 0? And then they would have just said cos 2x, where is it equal to 0? Then they would have said the reference angle is just shift cos negative shift cos 0. And then the reference angle would be, let's see, I think that's 90, is it? Shift cos 0. I mean, shift cos 90. Shift cos 0. Shift cos 0 is 90. Yeah, so the reference angle is 90. Do you see why it's important to have a reference angle? Because now we can say, okay, we're working in, we said if you're using a 0, just work with the positive quadrants. So if you're working with the positive quadrants, you would now then say, okay, fine. In the positive quadrant, you would work in the first one. So in the first one, that's where cos is a positive. You'd have there, 2x is equal to your reference angle. Then divide by 2 on both sides, x is 45, which is this answer. And then cos is also a positive in this quadrant, in the third one. So in the third quadrant, we know you would say 2x is equal to 360 minus your reference angle, because you go 360 degrees minus 360 minus your reference angle. You would have here 360 minus 90, it's just 270. And then the moment you divide both sides by 2, you have 135 equal to x, which is also going to give you that 135. So you can see many ways to do the same thing. You can either just use what you know about a basic sketch, or you could go right on and just work it out algebraically.
Yeah.
So now you know your x values. You can just say, okay, the graph is going to be below 0, where x is bigger or equal. It's going to be bigger, or it's going to be smaller or equal to 0, where x is bigger or equal to 45 degrees, or where those same x values are smaller or equal to 135. So you can write it like this. Other ways you could have just said it is, you can say x is smaller or equal to 45 degrees, and then you can say, oh, x is bigger. No. Other way. X is bigger or equal to 45 degrees, or x is smaller or equal to 135. See, that's another way to write it. Another way people would have written it out is they could have said x is an element of positive 45 up until positive 135. I might just remove this because it's gonna make it look weird. Zoop. So whichever way you write out, it's 100% up to you. You can write it like this, write it like this, or write it like this.
Yeah, it's cool. Got it.
Nice. Okay, so let us move on to the next one. So the next one now, it's a similar vibe because it's also just dealing with the picture, you know. So it's also just dealing with y values, because as long as you understand what the question is asking, it's usually easier to answer it. The problem is normally when you don't understand the question, you see, or when you don't know what it's asking. So normally if you at least know what it's asking, even if you don't know how to work it out, it's going to be easier for you to learn how to do it because you understand what they want. So here they want you to work out where the y values of f are above the y values of g. Because that's what this means. Where are the y values of f above the y values of g? So if you look at the picture is showing you very nicely. They meet here and they meet there. Now we want cases where the values of f are bigger than the values of g. So f is this coarse graph. We can see f is above the graph of g over there, and it's above the graph of g over there. Because it's a matter of comparing y values, you know, as you move from left to right. You see, the y values up there are higher than these y values down here. It's higher all the way until here, and then the flipped script, then things swap around. The graph of f starts having y values that are lower, while the graph of g has y values that are above. You see, so they just want us to work out where the y values of f are above the y values of g, and that's only happening here where we see the pink. Those are the only cases where the y values of f are greater than the y values of g. So here you see it didn't say greater or equal to. So meaning when we answer our question, we have to say that the x values have to be between 0 and this was a 30 in our previous question, and then we said this was a 150. So the answer here we'll have to say x is an element of 0 up until 30. The 0 is included, the 30 is not. And then here we can say, oh, x is an element of round bracket. X is an element of 150 all the way until the 180 with square brackets. See, because we can see that at 180 specifically, f is above, and then at 0 specifically, the graph of f is above the graph of g. So it's only happening from 0 to 30 and from 150 to 180.
Okay.
Yeah.
Yeah.
That's the way we like it.
Yeah.
So yeah, all that is on the main channel in terms of like small tutorials, right? You can always just find that on the main channel.